All right, so how does velocity affect position? So if velocity is positive, then position is increasing. And we'll think about why in a second. If velocity is negative, then position is decreasing. And if velocity is 0, then position is constant, meaning not changing, meaning that thing is just staying put. Okay, so why should this be the case? Remember that velocity, let's just use v, that velocity is the derivative of my position function. So for an example, here's time, here's some distance units. I think I'm going to copy that. So my position is how far off the ground that particle is at a moment in time. Say my position goes like this. That's increasing. I'm happy if that's my money, that shape. And do we see that velocity is positive here? All the slopes of the tangent lines to the position curve are positive. You can increase like that. You can also increase like this. Let's go ahead and label P of t. I'm sorry that I'm using P and S. Let's do S. Our textbook uses S, so let's be consistent. S for position. Position. Here's your position curve. Position is increasing. If I look at this, I'm happy with my money. And do we see that velocity is in fact positive? Absolutely. All the slopes of the tangent lines are positive. Positive slopes, therefore positive velocity. Okay, now if velocity is negative, then position should be decreasing. Let's think again about why this would be the case. So if I sketch some graphs of my position function, scooch these down. Think of being unhappy with your money. Here's your position function. I can be unhappy that way. I can be unhappy this way. Both of those curves are decreasing. And velocity is the slope of the tangent line to the position function. It's the derivative of position, and all of these slopes are negative. Negative slopes therefore negative velocity. Okay, and lastly, if velocity is 0, then your position is going to be constant. Why should that be the case? Let's investigate. Time and your distance maybe your position function is constant all the time. Maybe this object is always 2 feet from wherever the start is. You know, my position is always 2. All of these slopes, so that's a constant function, all of these slopes are slopes of horizontal lines. All those slopes are 0. So maybe your position function is constant all the time, or maybe it's just constant at brief moments in time. You know, maybe we're increasing and then decreasing and then increasing again right at these brief moments. The slope of the tangent line is 0. What is the slope of the tangent line to my position? It's the velocity. Oh, if velocity is 0, then my position is constant. Your slopes are 0, then your velocity is also 0. Excellent.